welcome. I'm George Gonzalez. I'm obsessed with making games. I love it, and I'm going to be making games till the day I die. I just know that. And today is Multiplayer Monday. So we're going to talk about spawning network objects today. And specifically, I'm going to go over these two setups because when you think about spawning network objects, you need to have these in mind. Okay, there's things that you set up in the scene, and then there's things that you set up that are spawned by the player. And when you're making multiplayer games, regardless if you're today's video is going to be on Fusion 2 specifically, but these principles apply to every multiplayer game. So as you're thinking about your multiplayer game, the first decision you have to make is this going to be in the scene, or is the player going to spawn him? And usually what determines that is the logic of what you're doing. And we're going to go over that. Just as a tip, if you are putting things in an environment and you're hiding them and then you unhide them later, that is not a good route to go because usually there's bugs that happen. Some depends on the network solution. If you are wanting to spawn things after scene load, then it's probably you don't want to do scene spawns. You probably want to have the player spawn. Or you might want to have a specific manager, but regardless, a player is going to trigger the spawn mechanic, and they're going to be have the state authority or the control over it, and they can change that around. And I'll show you how that is in Fusion 2, and you can look it up on how to do it for your network solution. But let's talk about this. So we'll start with scene. Why would you want a scene specific? So I have this horde spawn mechanic. Okay, usually most of my network things right now are with spawning enemies in the game. Okay, so sometimes you think, oh well, that's usually a scene thing. Well, it depends. It depends on what the result is that you want. So in this scenario, horde mode, right? You are in a group. And so for this reason, you'll look into this. We'll look into this horde mode. The reason why we are checking if a player enters the scene or enters this trigger, and then we start the wave. So as long as there's a player, it doesn't matter which one in the group is, it will start spawning monsters. But it only happen like the person who has authority will trigger it. And the reason you always have to check who has authority because you can't just control a network object without the state authority. And we'll go over certain edge cases where you can do that as long as you're aware of what's going on. So let's start with this mechanic. So what happens is as the possible monsters and the locations and enemies per wave and the delay. And so all these variables are checked by the state authority. And the main thing the first thing you want to do is check is master client object in Fusion. In Fusion, Photon Fusion has this mechanic for shared mode when you are all proxies in a sense. One person is the master client. And if someone leaves, if the master client leaves, Fusion will take care of swapping over the master client to the next. And in Fusion, what you can do, and I think I don't have it, in here you can say I state authority changed. And this is from Fusion. It's an interface for when the state authority changes. And so then in here, I could say if has state authority. So what happens is in here, when the state authority changes, what I could do is, if you don't have state authority, is destroy previous monsters or something. I don't know, like, so this is in case like you still have monsters lingering from previous, but you'll probably have state authority over those monsters too, regardless. So it doesn't matter. Okay, so this is where it gets complicated. So I want to go over specifics first, and then I'll show you how these things can get messy, but how you can keep track of these things as you go. Okay, so it has state authority, and then here I can say logic to reset or make sure any variables are adjusted. Because what happens is, let's see in here. So this flow, for example, wave delay. If you change this at runtime, it's only going to change for the local player. Not the so let's say you have I don't know if you're, let's say this horde mode is dependent on the level of the players and you change the wave delay, like, so it goes down as the more experienced players play. So the owner or whoever, like, let's say created the room or is like the host, if that player is level 1, then this wave thing might be 10, and then it changes authority, but this guy is level 50. Whatever. So you're going to lower it for him because it's more difficult. So if you wanted to adjust the difficulty based on who has ownership of the thing, that's something that you could do here. But if you want this to be always the same, or if you're going to change, you're going to change this. I know I'm not going to change this. So these are all stacked. So I don't need to have a network. But if I know I'm going to change this at runtime, and I want to make sure that they all are the same, I want to have a network component in here. So all these right now are, I know they're going to be this way when I set them in the prefab. So if I put them in the level, I'm going to adjust it and put the numbers that I want right in here. I can adjust these numbers and leave it in here, and I can do something different on the next scene. And so that way I can do different horde mode mechanics that are harder, or different enemies in here. Okay, so that's the first thing. And so that's why it's a scene thing. It's a scene network object, is because I don't care who's the host of this. I want to make sure that in here the mechanic happens here, and it's constantly tracking of that. So the first thing to make sure is you have the is master client object, because what this will do is anytime this is transferred, the master client is transferred, because the scene, let's say someone started it and then they left, someone new is going to be the master client, and so that keeps this from giving errors. Because if the master client leaves, like let's say it's set to that, and no one can have authority, it will destroy this. So let's say it's like that. These are the settings. When the player spawns, he'll have authority over this mechanic. And then let's say the player decides to leave. Then this thing will destroy when state authority leaves, okay? There's no transfer of authority, it just destroys. And so then that horde mechanic is no longer there. So usually things that you want to stay in the scene as network objects, regardless of who's there, and that way when they leave or they come back or whoever's coming as authority, this is how you decide that, right? If you want this and then like have this might be similar, okay? So you're not going to destroy when it leaves, and you're going to change state authority. The problem with this is that it doesn't do it automatically. You have to control that. And so let's say a player leaves. I'm not sure what this is going to do, right? Like Fusion might give authority to someone else, but you don't know who. And so you have to check. I haven't tried that because I don't want to. Like, I just have this. If I'm going to transfer authority, I'm just going to leave it to that. But anyway, so this state authority means that anyone can have state authority over this object, and you don't know who, and so it gets kind of confusing. But it might have similar results, but there's no guarantee, okay? But there's something that you can test out. So if I wanted to learn what this does, I would put this, I would host it, I would play with some other players, I would see who has state authority, leave, and see what it does. See if it transfers authority. But I don't like to do that, and usually there's a lot of bugs that happen. So this takes care of that, at least for the scene. If you want different behaviors, like if you do want it destroyed when the host leaves, then you can do that. Okay, it gives you flexibility to do what you want. Then, so that's the scene in specific, and I want to make sure I'm giving you use on spawn and master client transition. So we talked about the transitions. So we have in here this state authority changed. Always make sure, because the other thing that I've seen the mistake is that a lot of times people will start on awake. You're used to doing that in Unity or at start. What will happen is that if you do these, Unity will call these, and it's fine to do. The problem is that if you have any network logic in here, you're not going to be able to. It's going to cause problems, because this spawn ensures that there's a runner. The runner is the one that glues and then networks everything. And so if you are trying to make sure that everyone has the same version or has the same network, this is called when a player is ready to handle this object on all one, the host, the master client, the proxies, the other clients. And so this is very specific to the network logic, whereas this is not. And so sometimes you'll do all these initialization stuff. You have no idea if, like, yeah. So this is what happens. This is like a rookie mistake, usually, that I see a lot. So how do you avoid rookie mistakes? Is get used to doing this with network objects, and then you won't have any problems. Even if they're not network, even if you know what you're doing, it's just safer to do this, because you have no idea what runs first or second in the start and awake, because each network object that's in the scene will have its own time. Like, there's no logic for what goes first and what goes second. So you're always safe just doing this. And you don't want to start doing game object.find with other network objects, because those network objects will also be on spawn. So if there's something that you need a dependency on, you want to make sure you spawn it. So for example, let's say this horde mechanic needed another network transform to be there. I would just put it in here and have this spawn that object, and then get a reference to it from the spawn mechanic. That way you don't run into problems, because I know with Unity, a lot of players are used to doing game object.find and then like putting it together and whatnot. You just want to be careful of that. It's hard to control or understand who goes first and where's what. Okay. Also, most games run, you set up a lobby or you matchmaking of some kind, and then you start the game, and then you're done at the end of the game and they close the game. That's good. But if you have some kind of MMO or some RPG or social interaction where players are coming in and out, the server max time is 24 hours. And you have to stress test that, because oftentimes what happens is things start getting weird when players, like, because these same network objects are constantly running. And so you have to make sure that the logic for these, like, dungeons or whatever it is that you have up, you have to understand that, like, just because it works when you're playtesting, like, you have to understand when you set it to live, these servers have a max runtime, which is 24 hours. If you want to, you can lock the server after maybe 10 minutes, and then that way it won't be used again. Those are things you can do, but you have to be aware of that. If you don't shut it down, the server, because you're still having players jump in and play, and there's no, like, end logic, it's just like people passing through in a social environment of some kind, you have to be aware of the limitations, and they can start getting buggy real fast. So try to keep it simple, and if you do have logics, try to test it, see what happens after an hour of play test or playing through, like, and people coming in and out, is it going to break? So oftentimes what I do is I set up a timer and say after an hour, just like, if close the server and let someone else refresh, because usually at the beginning there's a lot of bugs, and if there's one bug, it's going to keep repeating, and it's going to just exponentially, like, create chaos in the network solution, because there's already a null reference, or there's a thing that's broken, and that thing that's broken is going to be broken for the rest of the session. And so that server is just, is poop, and so you don't want to keep that for long. And so if you have a timer for like an hour, then even if that happens, someone else can start a new server after an hour. It'll lock, and no one else will be in there, and so it mitigates those problems. Now we're going to talk about player spawn. These are specific to the player, and it doesn't necessarily mean that only the player needs to do it. You can, okay, with player spawns, is spawnable. This is the first thing that we have to make sure in Fusion, at least. In here, when we have, let me check, we have this flying eye. This is our only AI for now. In here, this is spawnable. This logic allows you to spawn this network object. And so whatever the engine, usually other solutions will give you what they need, or is spawnable. And as you notice, doesn't allow state override, and it's not master client. And the reason for this is so that if I spawn something and I leave, it'll get destroyed. And so that way, let's say you have these guys, it spawns for me and spawns for another player. If we have 5 people, there might be 5 different spawns, and we're all fighting. And if I decide, let's say, to fight a boss or something, and then I leave, that boss spawned and it stays there. And so then when someone else comes, like, either it'll spawn 2, or maybe I'll just keep it. But if it's bugged or something happened, it will stay there. And so if it has this allows state authority override, or is master client, it might have logic that's predetermined for the other guy. So you have to watch out for that. But you can do this if you want. Let's say every time it spawns, I want to kind of like, what is it called? It's not reward, but it's if you have more players and you want to keep, let's say 5 players are playing the dungeon, and it's hard because there's 5 players, and so the enemies are being spawned regardless of who it is, like in the horde mode, and I don't want the wave of the horde mode to disappear. So I'll just create is master client object. So I could create like 2 different flying eye monsters, one with this is master client, so like a master client enemy, or a non-master client enemy. And the idea with this is that, let's say we have a horde mode, and someone spawns all the enemies, and then the player leaves, and then all the monsters are destroyed. What happens then, right? Like, is there a logic for that? And that's what you gotta be careful. So in this scenario, you'll notice we have flying eye, and we have this network transform. So this flying eye moves from place to place. And so I want to go over certain things for this that I want to make sure these are specific. Is spawnable, has state authority, and be aware of variables. So I'm going to show you with this flying eye. We're going to go more in detail. But the gotcha with these spawnable eyes is that you'll have a network object. So this is a network solution script. And you have a network object here and a transform. Okay. Because you have this, you'll automatically think that everything's networked. Okay, it is not. And so you have to be careful about what your logic is and what you're thinking in your head, because oftentimes most of the bugs come from expectations. We think one thing is going to happen, but the computer is very not smart. It's just actually the opposite of smart. It will do exactly what you tell it to, even if it's not correct. It doesn't read your mind. It just does what you told it to. Okay, and that happens even more so with network solutions, because you have to think about, that's why I have this infographic here. You have to think about the player that has state authority and the proxy player, what's going on with these variables, the logics, the RPCs, because you think things are happening one way and they're not. Okay, so you have to go back to the drawing board and say, okay, what is actually happening for the player? What do I think? Usually the best way to debug these is to say, what do I think? What is my expectation of this behavior? I think this will happen when this happens, and you write down the sequences, and then you go and play with someone else, and you have to go through and say, okay, like, let's recreate the scenario and see if what I'm expecting happens. And then when it doesn't, you have to backtrack and say, okay, where did it go wrong and why? And then try to understand, because oftentimes they're like, well, sometimes there's no documentation that tells me why this logic is off, right? And so we use maybe ChatGPT or maybe what we know or what's available. Okay, so the first thing is has state authority. You always want to check if you have state authority. As you notice, there's like local floats, and we talked about this in the previous one. You have variables that are non-network, you have to be very cautious because non-network variables can be changed by anybody. So for example, I can have someone else change these intervals locally for this guy. So I would probably not make them public because someone can just say, well, I want to change them. The main problem is that, or let's say someone hacks my game, okay? They don't have state authority, right? They don't even host the game. They just came in and they see these public variables and they're changing stuff, thinking they're all cool and dandy. The only thing is that because I'm checking who has state authority, like the only person actually using these numbers is the local, like the player who has a state authority. So until that changes to that player, it doesn't really matter. So I could maybe create an easier enemy for myself. So these could probably just be private or serialized or static, whatever you want to do. Obviously, right now I'm just experimenting, like I'm testing, I don't care. But eventually I'll probably lock these, right? We have animation curves. Then in here we have a network quaternion. And this could probably be different. But for now, what I'm doing, and this is one of the gotchas that I want to talk to you about, is this. Because the rotation of my character is not revolve around this thing. Because see how if I rotate, it rotates the whole thing, right? So I think I have a rotation offset that rotates in the eye, right? So like to make sure, so if I had a rig and I wanted these things to stay still, I could, but right now I don't. And so it's very specific. So this is a rotation offset because this is going to move, right? And so if this moves and this rotates like this, it's not going to aim very well. Because the idea is that this aims where the eye is looking at, right? So that's what I want. I want the forward vector to be where it's rotating. And I also have, I believe in here, a shooting point. So this is where the shot comes out of. He shoots from his eyes. Pew, pew. Okay. And I have this rotation offset so that way it can shoot straight from the eye regardless of where it's rotating. Because if I did another type of rotation, because I'm rotating where the player is at. So that way that's like the tell of the monsters, that the monster is rotating. And when he's rotating, you know he's going to shoot. Okay. And this rotation offset is not networked. I could put a network transform here and look it up like this, like another network transform, but I just wanted to do it myself because it wasn't working for some reason. And so you have options and you have to debug. And so for now, and I still need to test it, but what I did is I have this quaternion rotation, and in fixed update, make sure it's fixed update network, because you're overriding, and this probably has a base. That's what I need based on. Okay. You always want to have the base because in case there's logic that needs to happen. So that's important because you're overriding. And if I'm overriding and I'm not doing the base, it means that I'm purposely ignoring whatever else has other code. And I don't want to do that. Okay. Rotation. And so what I do is I have this pivot and I want to rotate it to that network object. So this is going to happen for everybody. And it's going to rotate it. So it's like, this is the alternate to using this network transform right here. What is it? Right here. So you either use this or you go in here and use fixed update network. Now, if you have other logic in here, you can disable the interpolation. This is specifically for when you're not using, let me bring it up so you can read it. I think if I do this, okay. In share more, if you're not using fixed update network and you're just using update or fixed update, you want to remove this and it won't do the interpolation because it'll be way off. Okay, that's something that you can do if you're like, for example, this has like a trigger, and so I'm constantly checking stuff. That might be something you want to do. Okay, I'm gonna make sure I don't have anything on. I don't even know. Correct. I don't know. But anyways, regardless, discard. that is spawning. Okay, now let's talk about a little bit about the client. So we talked about variables, like we have the variables that are local, non-network. We have logic. We have to be aware of who's doing the logic. Is it the state authority? Is it everyone? Now, if you have everyone doing the logic, it'll get wonky. So for example, if you're moving the player, you have this network transform, it is gonna not work for the clients if the clients are moving it. Okay? So there's very specific things that if things are tied to a network object, then you don't want to touch them. But sometimes you'll have logics that you want all players to have. So it's a neat thing to have, or like when you understand these and you say, okay, now I want to go off script and I say I want certain parameters to always be happening on everyone. Usually this happens with game managers or not singletons. You don't want to do a network singleton, but you might want to do like a game mode. You have a game mode. Usually there's certain things that you want to track with the game mode that are specific to that player. So when that player spawns, do something for that specific player, or make sure they're in the correct team, or this or that, and those are valid. And sometimes those local variables, you can use them knowing they will be different. And as long the two criteria is one, knowing that they will be different on each one, and the second one is that you're not going to use them on other players. So if these are things that you want to track locally for that specific player and that specific script that's networked, then do not. It's okay, you can use them. Okay, but oftentimes, like the main problem is when you start mix matching without knowing, like you don't have a purpose and you don't understand what's going on. And so that's why I'm trying to do these videos, is so that you get a grasp on certain principles and ideas with networking. It's like you have to be aware of who has authority, who's doing the action, and why you're doing it, right? Like that way. It's like if you don't have a network variable, why is it not network? And that's okay. Like I have tons of non-network variables because I don't need to network stuff. And so you got to be very conscious as what you're networking and why. And you have to be resourceful, because I think once you understand multiplayer games, you understand that most of the logic is local, and you're saying, what is the minimum thing that I need to make this multiplayer? Like, is it a transform? And that's all. Like even like bullets, you can have an RPC call. So that's the other thing with RPC calls, you can get in a lot of trouble. Not no. And this is usually the same for most of them. So let's do, so RPC calls can be done in this scenario. The source is all, so anyone can call this, okay? So the reason why is that when you start the wave, it starts the wave. So we have on trigger enter. If there's a player inside, start the wave. If, where's the stay? There was a on trigger stay, but let me check. Okay, spawn next. So after the delay, start the wave. Okay, so we have here on trigger other player, object has state authority. So technically, this can be this will only be started by state authority. So I don't know why I have spawn enemy, start wave, and spawn enemy. So this spawn enemy really doesn't matter. I think at some point I had it where everyone can spawn this, but then I just said, okay, no, like it gets too crazy. So we had like a bunch of enemies. So this can still be state authority. So technically, this doesn't even have to be an RPC, right? So I just found I don't need to do this RPC. Maybe what I need to, and this spawns a network object. So this spawns the network. So an RPC is something that you want to call when you want to do things on multiple. So let's say this monster is local and it's not networked, and I wanted to spawn the same monster on everyone. So let's say, for example, I don't know, like if you break this glass, monsters will come out, and everyone has to face a mirror image of themselves, right? Like let's say, and so it's like a trial, right? And I don't care, like no one's gonna fight against my enemy. I'm gonna fight 1v1 with him, and my other players are gonna 1v1, and you can't see the other players. So for some reason, let's say that's the case. In that case, you'll do an RPC, and it will go to everyone, and you won't do a runner. You do a Unity instantiate, and that will spawn a monster in each one that's separate. Maybe you want to shoot a bullet, and instead of doing a network bullet, you can use this for that. Maybe you want to, when the game's won, or let's say we are doing a puzzle, and maybe the puzzle is local player, but when it's done by one player, it triggers an event for everyone, and it opens the door for everyone. In that case, I'm going to do an all, and it will go to everyone. So the idea is that everyone can finish the puzzle. The first person that does it will RPC everyone else, and it's like a call to them to say, hey, we beat the puzzle. The only thing is that RPCs are not guaranteed to get there, or to get there like for everyone. Because let's say, especially in VR, if you have the headset off, you don't receive that, or for some unknown reason your internet lags or something, you don't receive that call, it's not guaranteed. So if you have something that you want to make sure 100% guarantee that is there, probably the most thing is to do a network variable. And so when that variable changes, everyone understands the call. So there's two ways to tell everyone that something happened: is a network variable or an RPC call. And RPC calls are more for like announcements or things that are happening, and like spawning is fine. And if it doesn't spawn on the other player, is fine. And you can debug, but just be aware of that if things are not going how you want with the RPCs, and oftentimes a rookie mistake that happens is RPC to RPC to RPC. Like you're RPCing to the state authority, and then the state authority RPCs to you, to everyone, and you're going back and forth. Sometimes you do need it, but most often, if you think about it correctly and how to solve the problem, you don't need two RPCs linked together. And so I would stay away from RPC and RPC to back and forth, because they're not, I say unreliable, but they usually are fine. But it could cause a lot of problems, because then you're like debugging, it's like, why is this not happening on this person but not this? Because maybe this guy got 2 of the 3 RPCs, and then it's like in a different state that the other person. And so it's very specific if you want to just send signals or notices to people that things are happening. Hey, everyone, this happened. Hey, everyone, this happened. Or hey, spawn this for everyone. Or hey, do this for everybody. But usually game logics, like a winning condition and other things you can do, just be aware that you could just do a network variable and just say, okay, this changed. Because also, if the player leaves halfway through, you always have to think about like, what would happen if someone left, or if the host left right in between. And think about those scenarios, because at the beginning it won't happen because you're testing it and you know what to expect. But once you launch the game live, all those, like, they'll be, if your game is successful, which I think everyone wants to, if when you launch a game, you have to think there will be thousands of players playing it, and they will be quitting, exiting, canceling things in all places at all times. So every bug will be exposed, if not thought out. And you can't test everything, but you have to be aware of that. Okay? What are things that I want to 100% sure that everyone has the same variable? Then to use a network variable. If I want to just say, hey, like, I can live with this not being called, or hey, this is a notification, it's spawning an enemy. If it doesn't happen, it's not the end of the world. So just be aware of that. And as you saw, like, oftentimes what happens is that you set this to a certain default value, and then later you go in and change stuff, right? Like I added this, and I don't need this object. I can just say has state authority, and I don't know why it's like this. Should be different color, but anyways, you don't need that like that. I could just have has state authority, and I added this last to fix a bug, and then I didn't realize that hidden here is an RPC call that I don't even need to do an RPC anymore. So it's really tricky, because unless you do what I just did, right, like go through the logic and look at it. I haven't done this code for a while, and I have a few videos from a while back when I was showing this live stream and trying to fix these. And that's when I realized, like right now, you just saw me live, and I realized that I don't need this RPC. And so you have to take the time to understand what's going on, QA it, maybe you have another dev look at it. That's why, again, I have a community and game devs to help, because doing multiplayer games is hard. And there's some tips and tricks, things that you can do. And that's why I'm there to help you finish your game. And oftentimes, like, there are so many variables, so many things that can go wrong. And so I'm trying to help people catch these easy mistakes so that they can focus on the important stuff, which is making your game and finishing it, so that you can have success, level up, and gain experience. And so we'll see you on the next Monday for another multiplayer lesson.